if you, I don't know if the custodian will leave it, but if you've got some parts together, you're welcome to like throw them back here on the counter and.
Oh. I like.
They're still connected in the back.
Okay.
It should be okay. I got class right next week. Wait, that's kind of crazy. 1, 2, 3.
Yeah, there's a lot of AP classes up here, so.
It's been and better for us. It'd be good.
Yeah. No,
We have a unit 3. We have a unit 3 test next class. What? Yeah, our test is. Am I crazy or did we get no warning for that? So I just saw this. It's vendors, but. Okay, guys. It's really just like. I have to do that. It's one of these like quiz, but like some tests. Oh my gosh. I'm literally gonna. Oh,
Thursday or Tuesday. Exactly. That's what I said. That's why.
No, I keep saying circuit. What's it called? Circuit. Circuit thing. It's not
In my house.
Okay.
If I come back, tomorrow during advisory and give it to you,
Then what?
then would there be like points taken off?
If I was picking it up today, yeah.
Are you not taking it up today?
I always put it on the board.
Yeah, but you said that you were going to take it up.
Well, I was planning on taking it up. I had a test next class, so I didn't want to take it from you.
Okay, cool. Never mind.
I'm glad you got it out of your system now. Okay, I need y'all to get out assignment 36 from your binder, please. Let me put in roll, and I'll tell you what we've got to get done today. Brady. Okay, so to start off today, I'm going to try to take some questions you may have had from assignment 36. That's the one we spent almost all of last class on. It had a total of 17 questions on it, and I had asked you for homework to please stick with it long enough that you felt good about 10 of them. So I suspect that there's probably a few questions you had started, weren't able to finish, should not have counted those as any of your 10, but if you know you need help with them, that's why I will start off with questions from that in just a moment. So any of those you have ready to go, I will be ready to answer in just a minute. But first, let me address the two handouts you picked up. So 37 is the test review. This one is significantly shorter than the last one because it's got significantly less concepts on it. So it's laid out kind of the same way. It reminds you we've done implicit differentiation in this unit. Gives you a few practice questions. Then on the bottom, it's got some bit.ly links if you know you need even more practice. You turn the page, it's got 2 or 3 related rate questions. So not trying to get you to practice them to death, just trying to remind you that related rates are going to be a big part of your test. So there's 3 of those, but then there is 9 different links there where you could get extra circuit or extra related rate practice if you know you need it, and those vary quite a bit from easy to difficult. A couple questions on derivative of exponential functions that probably shouldn't take more than a minute or 2 of your study time, but there's the extra practice link there. And then finally on the 3rd page there's 1 practice FRQ that's required. The whole back page is just the answers to the test review. So, a big portion of what you should be doing today is working on that and getting any help that you need on it. The other handout you picked up is 37A, and the reason I didn't give it its own number is 37A will be optional. I will not ask you to turn it in. I'm suggesting that you practice those because FRQs are either worth half of your points on each of our tests or almost half of the points depending on the test. And FRQs are usually the hardest part of our tests, just like they're the hardest part of your AP exam. It doesn't really seem that way from the first couple, but your first 2 tests, those weren't real AP level FRQs. You don't have enough calculus under your belt at that point. So, in exchange, if you do some of that 37A, the optional FRQs, I will take some of those same question types and make them the FRQ on your test. So they won't be the exact same questions, they won't be the exact same numbers, but if you do those practice questions, you should find some parts of the FRQ on your actual test familiar. So that's the trade-off. If you're willing to do a little bit extra optional work, you should plan on that part of the test being a little bit easier for you than for people who didn't do that. So just a trade-off. So any questions about the new handouts? 37 or 37A? Okay, just to be clear, if you want to practice 37A, it's totally optional. And I'm only saying that because, like, if you scan the first FRQ and you say, I'd like to practice part C because I don't know if I can do it, but I don't really want to do parts A and B, it's optional. So do part C if that's all that you want to practice. Okay, so I didn't take up any assignments today because I, just on the far right of our agenda here where I always put our tentative date for the assessment, once I think I know what it is, our assessment has been planned for next class. Tomorrow is an A day, so I don't see you tomorrow, so that wouldn't be tomorrow, that would be Tuesday. However, I am making a quick adjustment here, so those of you that are paying attention, this is where it helps because you're going to know what's going on versus other people. So I was planning on doing the tests on Tuesday and then a circuit on Thursday about how to use your calculator and making sure you know all of the calculator skills you're supposed to have for this class and for your AP exam. Then I thought about how Wednesday was kind of a messed up day next week because it's the PSAT training or PSAT testing for some of you. So I'm going to swap those 2 class periods. So your test will not be Tuesday, it'll be Thursday. But 2 things to keep in mind. One is, this is still technically your test review today. Tuesday we're going to be doing the calculator circuit. So it's not calculus specific stuff, but it's, you know, solving hard equations in your calculator, making sure you know how to do that, because that's an expectation. The other thing is, just because I delay the test by 2 days, that does not benefit you at all if you don't take advantage of it. If you just procrastinate 2 more days before you start studying, then I'm not doing you really any favors. But if you study a little bit or aim to be ready by Tuesday, then I guess it actually being on Thursday would then be considered extra time. And I know a lot of you guys next Wednesday won't have a lot to do, maybe advisory, maybe community service, but unless you're a 10th grader that has to take the PSAT or an 11th grader that chose to take it, you probably will have lots of time Wednesday morning that you could use to study if you felt like you needed it. So I felt like that was a good trade-off. So I'm not going to bother to change the agenda here. So again, people who don't listen very well or who are absent and don't watch the class recording, they just will come in the next class thinking there's a test, I guess, but that's what they get. Okay, so I will remind you about Lake Worth policy stuff, but that's the only reason I didn't take up assignments today. All of these recent assignments, you guys know I give you at least participation points for most everything, so just make sure you keep that in your binder. You'll still get points for it, I'm just not taking them up yet. Okay, now we got all that out of the way. I want to offer some help on 36. 36 was the one that had 17 questions, and I said you need to stick with it long enough to feel good about 10 of them. So some of you need to finish up a couple more. So if you don't have questions and you just need to do a couple more, go ahead and start there. If you finished and you don't need any help, obviously don't sit there and be bored. Move on to 37 and start on it. And as always, if somebody's asking a question that does not apply to you, if somebody asks a question that you're good with, just use that time to work a question or two on today's handout so that you're moving in the right direction. Okay, so from assignment 36, which of these questions did y'all try and not be successful with? Number 8. Yes. Okay, number 8. In the triangle shown above, if theta increases at a constant rate, so that's not what theta is, but the rate of theta, so theta prime, if it increases at 3 radians per minute, bless you, what rate is x increasing? So that would be x prime is what we're trying to find at the moment when x equals 3 units. Okay, so we've got this picture. They made a picture for us. It's a right triangle. They gave us some of this information. I would totally understand why, as soon as you see a right triangle, that you're going to think that it's Pythagorean theorem. Pythagorean theorem's the most common type, but once you take the derivative, you realize, wait, this has nothing to do with theta prime. So this hint is either a distractor or it's just not Pythagorean theorem. In this case, it's not Pythagorean theorem. There is a way for us to make an equation that has x's and theta in it in this right triangle.
Sine.
Okay, what about sine?
Sine of theta equals x over 5. You take tangent of that. Right?
Okay, how'd you set this up?
Derivative. Excuse me? How do I or how do I?
Yeah, what's this process called? What math thing did you have to know to be able to do that?
Trigonometry. Geometry. Sure.
SOHCAHTOA. You were doing so good for a second too. Okay, so if you know SOHCAHTOA, you can set up the equation, right? So this isn't just memorize area of a circle formula, memorize volume of a cone formula. You actually have to piece together an equation using SOHCAHTOA. So those of you that skip pre-cal missed a whole lot of this practice. You still learned it in geometry, but it's probably harder for you. So now I can take the derivative. You know, this semester is 90% about derivatives. So the derivative of sine something would be, okay, but I just took the derivative of a theta something with respect to time. Related rates are always with respect to time. So this is going to create a theta prime. Just like this over here is going to create an x prime. This is 1/5 x, so the derivative would be 1/5 x prime. And that's your two big hurdles. First hurdle is coming up with a SOHCAHTOA equation to start with. Second hurdle is taking the derivative with respect to time correctly. But then you should just be able to plug in 3 here. X prime is what I'm solving for. The last question mark here is what cosine is equal to, or cosine theta. What is cosine in this question? Very good, 4/5. If x is 3, this must be a 3 what 5 triangle? And cosine is adjacent over hypotenuse. So the information was there, it just wasn't, you had to work for it a little bit. So I don't know, multiply both sides by 5 and you get x prime is 12. Yes.
When you take the derivative, do you just, like cosine theta, do you just put, or sorry, sine theta, whatever you, I guess, when you're taking the derivative, you just put a prime on anything that isn't time related?
Correct.
And everything.
Uh-huh.
Okay. I thought you weren't supposed to put a prime on x.
Is x the same thing as t?
No.
So, okay, so what you're mixing up, and that's understandable at this point, is before we got to this topic, everything we had done this year was taking the derivative with respect to x. So you would do the power rule as normal, but because you were taking the derivative of x stuff with respect to x, remember how we talked about this as essentially multiplying by 1? But in this question, we were taking the derivative with respect to time, because it's a related rate, of, what was it, sine theta? So sine, the derivative of sine something is still cosine something, but you have to realize, wait, I just took the derivative of theta stuff with respect to some other variable, and this is probably not 1, so it is incorrect if you don't keep up with it. Over here it's like 1, so we don't need to write times 1. But so yes, anytime you're taking the derivative of a variable that doesn't match what you're taking it with respect to, you have to create that prime. So with related rates always being the derivative with respect to time, you're taking the derivative of x's, you need x primes. You're taking the derivative of y's, you need y primes. You're taking the derivative of thetas, you need theta primes. The only time you wouldn't create a variable primed is if you were taking the derivative of t, which honestly just doesn't happen much. And to make sure that you really understand that point, because this isn't just related rates, this is also implicit understanding what you're taking the derivative with respect to. On today's test review, question 5 and 6 are kind of weird questions, but they're trying to really get you to focus in on when you need the prime and when you don't. So try those and you'll know if you understand it or not then. All right, Gabby, I think that was yours. That's okay? Yeah. So once again, I know you're sick of hearing this. I'm sick of saying it, trust me. I've got three AB classes. But you don't have to make SOHCAHTOA equations all the time in calculus. You're going to have to do it another 4 or 5 times the whole year. But you can see this was a real AP question where they expected you to notice, recognize, and remember how to do a SOHCAHTOA equation. And for every one of those past math skills that you don't remember, can't see, and don't pick up as they show up throughout the year, that just becomes more and more questions that you just don't even have a shot of at the start of your AP exam. So the good news is you guys know you don't have to get a 60% to pass the AP exam, right? To get a 5? Well, yeah, you got to get better than 60% to get a 5. Yeah, the cut score changes every year, but if you get 70% on your AP exam, that's pretty much a guaranteed 5. If you can get 70%, yes. If you can get like 50%, if you get 50%, that's at least a 3. So
I mean, it's kind of close. Like it's 50 to 60 to 70 in that range.
yeah, honestly, it doesn't take much work to go from a 3 to a 4 and a 4 to a 5, and very little work to go from a 2 to a 3.
Yeah.
One of my students last year, like they shared data with me, but I can see that if he had gotten one more point right, he would have passed. So I wish I could say his name, because then y'all would know that it was real, huh? So, yeah, next year I'll be talking about Johnny and how he missed it by 1 point.
Maybe. Or passed by 1.2. I don't know. I think anything can happen between now and then. See.
No, not anything. Doing your homework and studying is what's going to happen between now and then. Thank you. Okay, can we get back to math? Okay, is there others from this homework that you have ready to ask? This basic related rates worksheet. 11? Sure. Oh, yeah, and I want to do the one I told you to say for the end, too. I want to do that one together in a minute. All right, question 11. When x equals 8, now this next part we need to read very carefully. The rate at which the cube root of x is increasing, what is that talking about? The rate at which this is increasing. It's talking about the derivative of this. Derivative is rate. So the derivative of x to the 1/3 would be 1/3 over x to the 2/3. So realizing this is talking about derivative, because it says the rate, is means equals 1 over k times the rate at which x is increasing, so times an x prime. What is the value of k? Okay, I have a mistake here, and I didn't mean to make this, and we have already talked about this in depth today, so it's good for y'all to see how easy this is to do. This is not the correct derivative. The derivative of x to the 1/3 is not just 1/3 over x to the 2/3. I didn't do something right.
You have to call it in.
Sorry?
You have to take it in relation to the t.
Right. All of these are taking the derivative with respect to time, so I should have multiplied by an x prime there. I took the derivative of x stuff with respect to time. And I didn't mean to make that mistake, but you can see how easy it is to gloss over that. You've got to be very conscious of it. Okay, but if you can translate this statement into an equation, and you can do that derivative carefully and not miss that piece I about missed, you could divide both sides by x prime. Both sides have an x prime, so they just go away, and that's nice. And then you can do a bunch of algebra here if you want to, but if this is 1 over some stuff and this is 1 over some stuff, that stuff must have to be equal. And we want to know when x is 8. So your answer should come from 3 times 8 to the 2/3. So I guess the last challenge here is knowing how to raise something to a fractional exponent. So 8 to the 2/3 is like squaring 8 and taking the cube root. So if you want to take the cube root of 64, you can, or you can do it in the other order. You could take the cube root of 8 first and then square it. Either way, you should end up with a 4 there and a 12 for your final answer. Yes?
How does he know to take the derivative or put an x on it?
Because I took the derivative of x stuff with respect to time. Related rates are always with respect to time, even if it doesn't say. Time is the variable that's moving and changing things. So back to our conversation. No matter what it is, unless it's a t, if you're taking the derivative with respect to t, everything else needs to create a prime variable. So even though we just had that talk, I still almost made that mistake. Okay, is that enough? Ms. Shipman? That's good. Okay. Okay, I do want to look at number 6 real quick. Even better if you guys tried it. Even better if you tried it and figured it out. But if you remember, I said save this one for the end. I just hate this question for 2 reasons. It just really bugs me that I feel like they made it unnecessarily difficult the way they worded it. So let's just go ahead and do number 6 together, and I can kind of point out what I don't like about it, and you can still see that it's still a fine question. It's just unnecessarily weird. Okay, in the figure above, PQ represents a 40-foot ladder. So I'm going to make it look like a ladder so I remember what that side was. With NP up against a vertical wall and NQ on the ground level. If the ladder is slipping down the wall, what is the distance RQ at the instant when Q is moving along the wall 3/4 as fast as P is moving down the wall? So this sounds like one of those standard Pythagorean theorem questions that you could take the derivative with respect to time to, and you could divide everything by 2 by. The first thing that I hate about this question, though, is how they refer to things as P, R, and Q. And links RQ and points Q and links PQ. That's, maybe it's just me, but my brain doesn't translate that into A, B, and C of Pythagorean theorem very well. So what I would recommend is just label them. Call the hypotenuse C, call another side A and another side B. So every time they're talking about Q, I'm just going to use A instead. Every time they're talking about side P, I'm going to say B instead. Every time they're talking about side R, I'm going to say C instead. So like right here, when it says, what is the distance of RQ? RQ is what I'm calling B. So finding the length of B is what I'm trying to find in this question. And the second thing I don't like about this, so if nothing else, pick up that maybe if you also dislike the P, R, Q, or X, Y, Z, or whatever, you can change it to ABCs. Just make sure you have some way to keep up with P becomes B, Q becomes A. Make sure you have some kind of diagram where you can figure out what is what. But the second thing I don't like about this question is this last clue. I always mess this up, or I'm bad about messing it up. Q is moving along the wall 3/4 as fast as P. So Q is 3/4 of P. Now again, I don't want to use P's and Q's, so P, the side opposite angle P is side P. So instead of saying P, I'm going to say B. And instead of saying Q, I'm going to say A. Again, that's just easier for my brain. Okay, and then if, I don't even know if we need derivative in this question, we'll see. If I'm thinking of Pythagorean theorem, instead of saying A squared, I'm going to say this stuff squared. I don't know the length of B. I do know the length of C though. What was C? 20, 40? 40. So notice, if I take that last statement and create an equation out of it, I can substitute it into Pythagorean theorem. such that it only has one unknown, B, uh, 1600. So this is 25b squared over 16 equals 1600. And I don't remember the numbers being so messy. But anyway, I could multiply both sides by 16 and divide both sides by 25. And take the square root of that. And you get that B is 32. Now, is B what I wanted in this question? Oh, so I'm done. If I had solved this for B in terms of A and replaced B in terms of A's, I would have known how big A was, but I could have plugged it in back here and solved for how big B was. And again, B is my RQ, so that's how I knew that was the answer. So I don't know if you'll ever see another question like this again, but if the letters bog you, rename them. And if you're like me, this last statement is pretty easy to mix up, so just be careful that you're making that equation correctly so that you can use it correctly. But it looks like we didn't even need the rates for that one. So but yeah, that's definitely my least favorite question. Okay, is there something else I can help with from this? Okay, I realize some of you probably still have a couple left to do since I didn't tell you it had to be finished coming in the class, so let me give you some time to start on that. Again, if you're already finished on that, you should move on to the test review, start to practice a couple of each question types that I have there, and I will also take questions from that at some point today. So if you do get hard stuck on something, just move on and be ready to ask.
Is there anything I need to turn in from Tuesday, like 33 or 34?
I did not collect anything on Tuesday.
Thank you.
exact same as I do. It's fine. What's the way to see?
Johnny, turn your phone on.
Oh, I can always use this. They don't put having my hours in for nature. Oh.
All right, is there a few more questions I can help with? Sure. Number 9. All right, the base of a triangle is increasing at a rate of 3 inches per minute. This is changing at 3 inches per minute, while his height is decreasing at 3 inches per minute. Which of the following must be true about the area A of the triangle? So, area is increasing, decreasing sometimes, and remains constant. Well, I don't know. I would just have to start off with area of a triangle is 1/2 base times height. So if I want to know something about his rate, I could do derivative. Derivative of b with h left alone plus b times derivative of h. So this is positive 3, and this is negative 3. And so for it to be increasing, what has to be true about the derivative for it to be increasing? Okay, and this guy, 1/2 is always positive, so positive times a positive. So we really want to figure out when this is positive. You could even maybe make an inequality there. You could add this over, and it looks like 3h minus 3b is only going to be positive when h is bigger. Doesn't that make sense? Because they're both being multiplied by 3, so if this stuff is being subtracted from this stuff, h has to be bigger than b for this to be increasing. Likewise, so it's not always increasing. It's only increasing if the height is bigger than the base. Another way to say that is it's decreasing when the base is less than the h. So that seems to be true of C. It's not always decreasing, and when B is bigger than H, this is negative, so this whole thing is negative. So I think it should be C. It is not. It is D. When B. Oh, I read the inequality sign backwards. My bad. When B is bigger, it's decreasing, because when B is smaller, it's increasing. Was there something specific in there? No? Okay, another question or two from 36 before I start taking questions from test review. Yeah. 10? 2. Alright, sides of a rectangle increase in such a way that the rate of z is 1, the rate of x is equal to 3 times the rate of y, when x is 4 and y is 3, we should be able to figure out what x prime is. So, lots of information there. They even gave us our picture. So, I've got a right triangle. Doesn't matter that it started off as a rectangle. It's the right triangle that I'm interested in. So, Pythagorean theorem, take the derivative, divide everything by 2. Are you okay with me skipping those 2 steps? Okay. I don't know. Like a few questions ago, I said rename the stuff. So if you want to rename these to A and B and this to C, just make sure you can keep up with that. I'm just going to go ahead and rename them right now. X, Y, and Z doesn't bug me for some reason, but... So there's the derivative. Just start plugging this stuff in. Z prime is 1. I don't know Z. Y prime, I don't know. Y is 3. X prime, I certainly don't know because that's what the goal of the question is. So that's going to be the last thing to figure out. And X is 4. So if I'm trying to solve for X prime, I can see that I need way more information. I need to figure out how big Y and Z are to even stand a chance here. But if X is 3 and if Y is 3 and X is 4, I can use this right triangle, do Pythagorean theorem to solve for Z, and that would have to be 5. So 3, 4, 5 triangle. So I really do know the length of Z. It just wasn't given to me. And we could do something here. I plugged in 3 for Y. This should still be Y prime. Sorry. Okay, so then if you realize I'm trying to solve for X prime and I've got to figure out Y prime, if you list out all the stuff they give you, it's a lot easier to see because you can see what things you haven't used yet. So we can leverage this and say that Y prime is the same thing as 1/3 X prime. And when you make that substitution, now you've got an equation that only has X primes, and that's what we're solving for. So now we've got 4 of these plus 1 of these would be 5 of those. Divide both sides by 5, and you end up with an answer of 1. Sorry?
I just matched up my thing.
Oh, okay. Did you see to make this replacement though? 'Cause that's the hardest part, I think. But
I just messed up my
oh. Okay, I'm gonna move on from this one for now. But if you still have others, I will still offer help there. Those of you that have moved on to the test review, any of the first 8 questions over implicit, or the other 3 on related rates, or the other 3 on derivative of exponential functions, any of those?
Could you do 8B?
18?
8B.
8B. I can. Okay. So, as always, Johnny, put his headphones in. If you want help with 8B, you need to make sure you're paying attention now, or you're going to be on your own later. So, if I take the derivative of this, because it's asking me to find dy dx, so I'm taking everything with derivative with respect to x. This is not related rate. It's not a function of time. This part, you're going to have to do product rule. It's x times some stuff. So take the derivative of x times sine of 2y left alone plus x left alone times the derivative of sine of 2y. And the derivative of sine something is negative cosine something, because of chain rule, I need to come back and multiply by the derivative of the inside, and the derivative of 2y would be 2y prime. Yes?
Derivative of sine is positive cosine.
Thank you. Is that better now? I probably mix that up more than you guys because I'm just going to make an excuse. But next semester when we do the opposite process, we're going the other direction, so the rules for the which one becomes negative and stuff flip around, and so that's probably what I'm thinking. Okay, same thing over here. Y times some stuff. You need product rule. So derivative of y with cosine 2x left alone plus y left alone times the derivative of cosine 2x. The derivative of cosine stuff is negative sine of the stuff times the derivative of the inside, so times 2. Now, it's important you understand why I didn't put an x prime there. I didn't put an x prime here because I'm taking the derivative with respect to x. There's no need for an x prime. When I took the derivative of a y, I have a y prime. When I took the derivative of this y, I created a y prime. Y and x are not the same. Okay, so that looks pretty scary, and to be honest, you've got some options here. You can either take a few steps if you want to solve for the derivative and then plug in the point, pi over 4, pi over 2. I think that's a bad strategy though. I feel like all this simplifying to solve it for y prime is not really needed. If you already have a point to plug in, I would just suggest plugging in the point right away. So sine of 2 times pi over 2, 2 times pi over 2 would be pi, and the sine at pi is 0, plus x times 2 times y prime times the cosine of 2y. So if I plug in pi over 2 for y, multiply it by 2, that becomes pi. The cosine at pi is negative 1. It's another y prime. Cosine of 2 times x is the cosine of pi over 2, which is 0, minus y times the sine of 2x. So plug in pi over 4 for x. This would be the sine of pi over 2, which is 1. And since this goes to 0 and that goes to 0, and that reduces, I think you get all the way down to that. I'm just letting this 2 cancel out this 2 and leaves behind a negative pi times 1. We could multiply both sides by 2 and divide both sides by negative pi. So I would say the answer is 2. Okay, and that's a terrible answer because I didn't even think about what the question was asking. Question wasn't wanting the derivative. The question wasn't even wanting the derivative at that point. Question wanted the equation of the tangent line. So a tangent line is always going to be linear. I really did all of that work to figure out that the slope at that point is 2 because derivative gives you slope. I already had the x value of the point and the y value of the point, but that's what they're asking for tangent line, not that. Okay. Is that all you needed from that? Okay. Anybody else going to ask about 8b while it's up there? I did have one thing I wanted to say about your Unit 2 test, if I can talk. So just because of this question made me think of this, but I was happy with how you guys did on your Unit 2 test, but I would say probably one of the two most missed questions was the one that asked you to make the equation of a tangent line. So knowing to format your answer like this was probably tied. It's either tied for the most missed question or it was the second most missed question. And that is concerning to me because equation of tangent line is a continual thing that we'll talk about all semester and a little bit even second semester. You're going to continue to see questions about equation of tangent lines. In fact, even on the test review on the FRQ back on the third page, the second question asks you to write the equation of a tangent line. So that's just a big part of calculus. But I guess while we're on that topic, I did have my last person finish up their Unit 2 test today during advisory. So that means next week, if you want to come in and see yours and see what you missed and why you missed it and all that kind of stuff, you're welcome to sign up. Just sign up for prime time as you always do. Remember, I don't let anybody see them until they're all taken. And like in the past, if you think you don't need to come see it because you made 100 on it, you could still have missed a question or two, I think, or at least one, and still made 100. So you should still want to look at your work, I guess. So I'll put that in Google Classroom because I need to notify my other classes, but I can also share with you the test averages. So here was the first one, the limits quiz. Y'all are lagging behind in last place here. But on the last quiz, y'all did better. So before and after curve was better than other classes. So what does that mean?
Like our period is best.
Huh?
Like our period is best.
Yeah, but how come you didn't do the best there then?
And we realize our mistakes and we do.
He said
Realize
he said to get an interview for the exam.
Okay.
Any comment?
Do I have any comments?
No.
I think you should all make 100.
Yeah.
If Johnny made 100, then you can all make 100. Okay, let me give you a few minutes apiece, work a few more questions, and I'll try to rest my voice here a little bit and help out some more. You still got 35 minutes. So again, you really need to have assignment 36 done because it should have been almost done coming into class. And you should be getting as much of 37 done as you can in class, especially since there's only a couple of each question type. So the test review will not be the focus of Tuesday's class. So.
Oh, so it's just like so fast. Do that.
John better hope he brings it back, since it's signed out to him.
We did also.
Huh?
I was telling Pierce we get it sorted out.
Okay, I'm back to offer some more help. Test review or assignment 36. Either one. Yeah. 36. Question 3, multiple choice. This one, person 2 meters tall. Okay. Okay, so you need to try to start with a picture here. Got a person that is 2 meters tall, and they are walking away from a light pole that is 8 meters tall. And so the light is hitting this person's head, coming to the ground, and then this makes up his shadow. And we know his shadow is increasing at a rate of 4/9 meters per second. And with all that information, we should be able to figure out how fast this guy is walking. So how many meters per second is he walking? So the first part of this is you got to come up with an equation here, a geometry equation that we can take the derivative of. So you need to first realize you've got a smaller right triangle here inside of this big right triangle there. The next part's a little bit of a stretch, but back in your geometry days, you should have learned that anytime a triangle shares 2 angles, they both have this angle. So of course it's the same size for both triangles, and then they both have a right angle. Angle proves triangle similarity. It's important to know that these triangles are similar because similar triangles are proportional in side lengths. So we can make a proportion 2:8, and it's tempting to make the other part of the proportion these, but these are not lengths, these are rates, so we can't mix and match. So you're going to have to call this maybe X, I don't know this length, and this Y, I don't know this length. But if I do small triangle to big triangle on the left side, I need to do small triangle to big triangle on the other side. So that proportion is kind of the key. See, once you get your picture, see if you can remember to make that. Now after that, you could cross multiply. You could take away 2 x's from both sides. You could divide both sides by 3. You could do a lot of stuff. But eventually, you need to take the derivative of both sides with respect to time. And when you do that, now, if I called this x, then this value they gave me was x prime. If I called this y, and this rate is what I was trying to find, y prime is what I'm interested in. So the final answer came from 3 times 4/9, which is 4/3. But seeing to set up that proportion, it's just not easy for some people, especially those of you that did geometry many years ago. Okay, you guys have another one from assignment 36 or test review. Help out either way. Okay, well, we still have a little over 20 minutes, so I'll set one last timer and offer to work questions out on the board one more time before you go.
What would be my next step going from here?
Get that. Minus. Okay, that looks fine, that looks fine, that looks fine.
Would these not cancel out?
Which ones?
Would these two not cancel out with each other?
Which two?
These two.
Like, this is an x plus 1, and that's an x plus 1, so it's tempting to cancel those, but you can't cancel out terms, things that are being added or subtracted. So, I don't know, if you're trying to find dy dx, it's right there. You just need to divide both sides by 2 and a y. So, divide this side by 2 and a y to cancel that, and then divide this side by 2 and a y. Puts it in the denominator.
Actually, where'd the 2 go?
Okay, well, let's flip back.
That's why I was gonna do that, but I just didn't know where the 2 went.
Well, if you distribute this 1, this is like x plus 1.
Yeah.
And when you distribute this negative 1, this is a minus x plus 1. So x minus x cancel out. And plus 1 becomes 2.
Oh, so okay.
Yeah, and then it cancels out that other 2. Okay, we have just a touch over 10 minutes, so I said I'd offer one more time to help out on the board. Test review stuff or assignment 36 stuff. 7. All right, I had a question for number 7 from the test review. All right, so immediately I can tell part of what's going to be a pain about question 7 before I even really look at it much is it wants second derivative. So It's just going to make the question a little bit longer. So all I can do is go ahead and just start taking the first derivative. So the derivative of a constant would be 0 minus 2 times the derivative of xy. So that has to be product rule. Now notice I'm taking the derivative with respect to x. So every time I take the derivative of x, I'm not going to put anything. But every time I take the derivative of y, I will need a y prime. So derivative of x with y left alone plus x left alone times the derivative of y equals, the derivative of 7x would be 7, and the derivative of minus 3y would be minus 3y prime. So there's 2 times you have to do implicit differentiation there. Now to solve this for y prime, I need to distribute this negative 2. You need to choose to either move all the y prime stuff to the left or the right. I just picked the left. Anything without a y prime, move to the other side so that you can factor out a y prime so that you can undo times with divide. Again, these are not the easiest steps, but at least with implicit, that's pretty consistent as far as all the y prime stuff on one side, factor it out as a GCF, and undo times with divide. So I did all of that to figure out that y prime, the first derivative is that, but it didn't ask for that. It asked for second derivative. And if this was a multiple choice question, this would probably be one of the answers, because they're testing to see if you are paying attention to second derivative. So now I can do second derivative, which is the derivative of the first derivative. And this time it's something divided by something, so I'm going to have to use quotient rule. So derivative of the numerator would be 2y prime times the denominator left alone minus the derivative of the denominator times the numerator left alone, all over the denominator squared. Now, there's something about this that does not meet the directions. There's a reason I should not circle this as my final answer. What did they ask me to do with the second derivative? Okay. Is my stuff in terms of x and y? How come? Why isn't mine in terms of x and y? That's an x, that's a y, that's an x, that's a y prime.
That's not otherwise or y prime?
Right, y and y prime are two totally different things. They're similar looking, but they're measuring different things. This is not in terms of x and y because it's in terms of x, y, and y prime right now. So how am I supposed to know what y prime is? Like, how am I supposed to get y prime in terms of x and y? I'm saying, like, how do I even know what to plug in for this? I don't want to move it over because I don't want to, I'm trying to solve for this. Right. Yeah, you need to be paying attention, but you already know what y prime is. It was just back here a step. So before the simplifying, it looks like our answer would be 2 times whatever y prime was times 3 minus 2x plus, I'm just going to multiply those, plus 2 times 7 plus 2y over all this stuff squared. But notice that stuff cancels. It's multiplying by 3 minus 2x and dividing by 3 minus 2x, so that goes away perfectly. I've got 14 here and 14 there, which makes up a 28. I've got 4y and 4y, which makes up an 8y. And if this was a multiple choice question, I'd start looking at my choices to see if any of them look close to that. And for this question, the only thing they did extra was they factored a 4 out of the numerator before they circled their answer. Okay, did that address your question? Okay. All right, so again, we do not have the test next class, but if you guys don't pretend and prepare like it's next class, pushing it down the road 2 days isn't going to help you if you just wait 2 more days to study. So consider trying to be prepared by Tuesday, and then waiting till Thursday will seem like extra time. Obviously, I will ask for a good handful of assignments on that test day because I have not picked up the circuit. I've not picked up this stuff. There's several assignments I want to give you points for. So if you're not finished with the test review, you need to finish that up. Almost every question's worked out on the website. It's all the questions my last 4 or 5 years have asked about, so it's probably going to address your questions. So feel free to keep working on that, but if you'd rather look at today's puzzle, you can. I think you guys saw this one. Did y'all do this one yet? Okay. All right, then you're on this one. Does anybody know what's going on in advisory tomorrow?
It's like a school-wide makeup day.
I know, but what do they mean by makeup day?
Just like your big advisor, I think, like your base advisor.
Oh, we don't know why.
I think it's because one of these Fridays we don't have school or something.
Oh, that's true. You don't have school on Friday in a couple weeks. So. Anybody got a guess for your answer? Is not 6,
Well, yeah, for sure.
not 12.
Where we're going with this early because it's like that's first like all the way over. That's so cool. Or maybe they don't die. But I feel like there has to be
I will post the answer and solution to Google Classroom.
how are we gonna get to know? I think like one person decided to back to their group goes and they show it to other groups. It's just they can so like everybody but you have a lot on this in your group. Exactly. You like figure it out like as one of the groups of like I'll ask around. You have I don't like just like doing it. You get to dress out.
So what?
15? Oh, you can do it in way less than 15. You can do it in way less than 15.
No. Is it higher or lower than 12?
Way lower than 12.
So is it higher or lower than 6?
Well, do you think you could do it in 5? Okay.
And then you do it in 5 races, you have 5 passes. Yeah, you do one more.
So it's more than 5.
So it's 6.
Song or idea or whatever. So
I didn't say it was 6. I said it was more than 5.
How is it now 6?
It's not 6.
Oh, now it is.
How?
Right now, we get that.
You do 4 races and you take the fastest in each one. You put them all together in one last race.
Yeah.
And then you take the top 3.
Yeah, but wait. You take the top 3 from 5 races. You can't fit them all in the 6th race.
You take the top 1 each race.
Yeah.
And then you take those 5 horses and race them all at once.
Yeah. But what if 3rd place in race 1 is faster than 1st place in race 2?
That's the only thing that I don't like.
Unfortunately.
It's unfortunate. The explanation's on Google Classroom if you want to look up why the answer is 7. Have a good day.